All right, so we're going to start. I'm going to explain 12H, boys, exponential functions. So I'm going to explain this, and then I'm going to stop, and then we're going to explain 12I. And we'll dedicate most of this lesson to 12I. And this exercise I'm going to make as an explanation, as invitational for you to go and do the questions. The questions, similar, they pop up in 12H anyway. So I figure we'll talk about H, and then when we get to I, some of those questions from H will pop up in there. So I've got a table of rules, okay? They're not things you need to memorize by any means, rather they're just sort of description of what the technical mathematics that's occurring. But maybe let's just get straight into a simpler understanding. We have exponential functions. So that's a function where the power is the variable, right? Compare that with what we were talking about last semester. Remember how we were talking about polynomials? So we had x to the power of 1 or x to the power of 2. So here we have the variable to the power of a number. Here we have the variable is the power. So that's the distinction, right? That's an exponential function. Now our first step is to graph the function. And whenever we're graphing a function, right, we've got some x-axes and we're putting those x values into the function to see what's the corresponding y value. So I've got this table of values and I'm just going to generate that to start with so that we can provide a graph from a table of values here. So the function, right, the function is 2 to the power of x. So I'm going to take the x value, I'm going to start with positive values first. So if I have 2 to the power, let's do this one, 2 to the power of 1, okay, what's it equal? That's going to be 2. So this means when x is 1, the y value is 2. That's one of the points that lies on the function. Okay, the next one. When x is 2, y is going to be 2 to the power of 2. I'm putting in x is 2, which is 4. When x is 3, I'll put another one there, I should have had that. 2 to the power of 3, which is 8. Okay, so we can see 2, 4, 8. Maybe a hypothesis about what's occurring next. Okay, x to the 2 to the power of 0. 2 to the power of 0, 1. Very good. Any number to the power of 0 will always be 1. Okay, here let's get to the negative powers. I have 2 to the minus 1. Now we know from index laws, that means 1 on 2 to the power of 1, right? That's half. So when x is minus 1, the y value is half. We can express it as 0.5 or as a fraction. 2 to the minus 2, that would be 1 on 2 squared, or 1 on 4. That's a quarter, okay? And then here we'll have 1 on, I'll write it out, 2 to the minus 3, that's 1 on 2 to the power of 3, that's 1 on 8. 1/8, 0.125. And so what we can see is, it's going down, it's dividing by 2 each time, right? Or you can see it doubling each time we move up. It's increasing by a factor of 2, and that's because the base is 2, right? It's doubling each time that we go up. And so from this table of values, we could sketch that graph straight away. We could sketch it from x is minus 3 to x is positive 3. So let's do that quickly, and then we'll bring it up in our calculator as well. So the table of values, I've got when x is minus 3, y is 1 on 8. So that's going to be pretty close to the x-axis. It's still positive, all right? On my y-axis, I'm looking at my highest value for y is 8. So I'm going to put 8 up here, and then I'll just scale that accordingly. 8, 4, 2, 1. So there's 6 in there. All right, the next point, we've got minus 2 at 0.25. We've got minus 1 and 0.5. We've got x is 0 and 1. We've got x is 1 and y is 2. We've got x is 2 and y is 4. And we've got x is 3 and y is 8. Okay? If we were to keep going, x is 4, we'd have y is 16. And this is, you've heard that word before, exponential growth. That each time you get further along, the rate at which it increases gets faster and faster and faster. That's just going to infinity real quick. All right, that's going to y, shooting up. All right, So there I've provided a manual sketch of it, right? What have I done? I've got a table of values, and from the table of values generated the graph. Now we can get this on our calculator as well, and it's important that we do know how to use our calculator to answer these kinds of questions. So let's pull our calculators out. We're going to go into the graph mode, menu, graph. We're going to graph the function y equals 2 to the power of x. 2 to the power of x. And the very first thing we're going to have to contend with is the V window. We want to set the V window so that we can see the graph. So if we've typed in 2 to the power of x, what we're going to do next is press Shift and F3. And that brings up the V window. That's the virtual window of the Cartesian plane. Now this is probably the most important setting that you'll have on your calculator. Anytime there's an issue, no doubt it's probably to do with the V window. So I'll just talk about the important things to get from here: the x min, x max, y min, y max. Okay? And these are the constraints of the Cartesian plane. It's the virtual window with which you're looking at the Cartesian plane. Here's your x min, here's your x max. All right? So for our purposes, I generated this from a table of values, right? So if we want a graph that looks pretty similar to this, let's set our x min as -3 and our x max as +3. So we're going from -3 to +3 on the x-axis. And on the y-axis, we didn't have any values that went below the x-axis. So we may as well set it as, for the y min, so we'll go from -3 to +3, the y min, -1, okay, so we'll just, so that we can see the x-axis, and then how high up did we go? We went up to 8. 8 was the highest we went. I did put a 16 here just to illustrate that. So if we've set those values for the V window, it should look pretty similar to what we've sketched here. Okay? And now from the V window, we can start to answer some of the questions we're presented with. Okay, graph the function, done. Part B, find f of 0, f of 1, and f of 3. Now, I've actually done them from the table, but let's talk about how we can use our calculator to do it. Let's press trace, okay? Trace corresponds with F1. Press trace. Now you can type in any x value. All right, just press the number 0 and enter, and it's going to take you to that point, and it will tell you both the x value and the y value. So we've got f of 0, 1. Also corresponds with the y-intercept, right? F of, what else are we asked for? F of 1 will be 2, and f of 3 will be 8. All right, so we can see they correspond with the table of values here, and we can trace them along on the graphics calculator. Next, use technology to solve the equation. We have 2 to the power of x equals 15. Now, we can start to think, what kind of value could that possibly be? We should know in our minds, right, or from what we've seen, 2 to the power of 3 is 8, and 2 to the power of 4 is 16. So it's going to be pretty close to 4, right? So we can see we've got 2 to the power of 3 is 8, 2 to the power of 4 is 16. So this power x has to be somewhere between 3 and 4, in fact, probably a bit closer to 4. So we have a rough idea of what it's going to be. It's going to be 3.8, 7, 3.9, something like that. So what we'll do, we're going to go G-solve. Okay, that brings up lots of options for the graph. We'll press the across arrow to bring up more options. And there are a couple of things here. There's xcalc and there's ycalc. We are trying to find an x value. All right, it says find x, solve the equation. So we're doing an xcalc when the y value is 15. So we type in x is xcalc when y is 15. All right. I'll punch this out as well, unless anyone's got it already. Thank you. Not found. Oh, we need to change that V window. Okay, let's jump back 2 steps. Let's change our V window. It's not found because it's outside the domain of our V window. This is good. Opportunity for us to troubleshoot. So we can't see it because the highest it goes is to 8, and we need it to reach 16. So that means for our y max, let's change that to 16 now. And for our x max, let's change that to 4. All right, so go back into your V window, change those. So I've got 2 to the power of x. All right, guys, you okay? Francesco, all right? Yep.
I mean, we don't have the calculator.
I'll bring it around for you to have a look at in a sec. All right, so from -3 to +4, and from -1 to +16. And we're doing G solve, X calc, Y is 15. Okay, we've got 3.906, which would round to 3.91. All right, so get in the habit of writing. I've written 4 figures, 1, 2, 3, 4, and I round the 4th one. We've stated it to 3 significant figures. When X is 3.91, the Y value is 15. Right, Francesco, while I'm teaching. Okay, so do we have any questions about that so far? All right, so we do need to be competent at these calculator skills, and that's all this exercise really is to chat about those. Last one, determine the equation of the horizontal asymptote. So what's going on is as we get further and further down here, we're going to get closer and closer and closer to the x-axis as I move more and more this way, as I get more negative. And I'll show you exactly why mathematically. Let's say we're going, here at x is -3, let's say we go all the way to x is -1,000. All right, if we go to x is -1,000, what the y value is going to be, it's going to be 2 to the power of -1,000. All right, 2 to the power of the x value is -1,000. That's 1 on top of 2 to the power of 1,000, which is 1 divided by 2 times 2 times 2 times itself 1,000 times. Like, this is an enormous number, right? So we have 1 divided by this enormous number. This is getting closer and closer to 0, but it's still positive. It's a very, very small. And so what's going on with this is getting closer and closer and closer to that x-axis, but it never reaches it. It's an asymptote, right? And so we have an asymptote at y equals 0. It's getting closer and closer to 0, but it never reaches it. Now, I'm going to compare that statement that I've arrived at with the general description of the exponential function. Okay, so right at the top, it's described as k times a to the power of x take c plus b. Now, the 4th dot point. The equation of the horizontal asymptote is y equals b. Y equals b. So we're comparing that with what we have here. Now, our value of a is 2. Our value of k is 1. We've got one lot of it. There's an invisible 1 out the front. There's no horizontal translation. C is 0. And b is 0 as well. It hasn't been shifted up. It hasn't been shifted down. It's the basic exponential function. And so the value of b is 0. The horizontal asymptote is 0. And that's confirmed here. All right, that's confirmed by that mathematics we've performed there. It's going to get closer and closer. Another way you can check is to just zoom right out on your graph, and you'll see it getting closer and closer to 0, but never reaching 0, never getting there. Okay, so this exercise, I just wanted to have a discussion about using the calculator around exponential functions. Now, if you have a particular question about a calculator skill, I'll probably ask people individually. Any group questions?
No, it's not about this.
Yeah.
So, why is 0 on the power of 0 is 1?
0 to the power of 0. Why is it 1? Can I think about how to answer that? I might have to think. Yeah. Good question though. 0 to the power of 0. All right. So let's move on to I then. Now I is divided up into 2 parts, I.1 and I.2. We're going to answer both of them. I'll stop the video and then make a new one in a sec.